And then if you typically title your notes, you can title it continuity. Okay, continuity. How's day 4 going? Good. Yeah. Only 176 days left. Not too far. Okay, continuity should sound like a word you did in pre-cal. What's the word?
Continuity.
Yep. So, continuous, yeah?
Oh yeah.
A function is continuous if, okay, in your own words, or probably in whatever words your pre-cal teacher told you, how do you know if a graph is continuous? Okay, it could have arrows. What can it not have? Poles or breaks, asymptotes, anything like that. So I'm going to put a function is continuous if it can be drawn without picking up your pencil. Okay? Function is continuous if it can be drawn without picking up your pencil. There are 3 types of discontinuities. Okay, the first one is a removable discontinuity. And a removable discontinuity is usually what pre-cal teachers will call a hole. Okay, so if you want to put that on here, that's fine. But as far as calculus goes, we need to kind of shift that vocabulary over to it's removable. So hopefully you remember sort of what that looks like. Draw a parabola, but then put a hole in any point along it. Okay, your graph is discontinuous if there's a hole. The second type is a jump discontinuity. And a jump is where both of your sides have a limit, but they're not equal to each other. So we've looked at a lot of examples of these in the last couple days. Let's say maybe one's here, and then the other one is at some other value. So they both have limits, but they're just not the same limit coming in from the left and from the right. That's called a jump discontinuity. The last one is an infinite discontinuity. And an infinite means that one or both sides have an asymptote. So on one side I'm going to put my same little quadratic, but then on the other side maybe my graph goes down to infinity and is not approaching a specific number. Now, your asymptote could also be up, it doesn't matter. But specifically, there has to be a vertical asymptote. So, horizontal asymptotes, like your x wouldn't be going to a certain number. It'd be kind of like the end of the graph. So those would not affect if it's continuous or not. Mainly just vertical. Okay? So I'm going to give you the kind of long definition. It's not that long. But I'm going to give you the definition that we're going to use for calculus. So put a big star here. This is what you're going to be using on your notes. A function f of x is continuous at x equals c IFF. Have you guys seen that before?
If and only if.
Yep. If and only if, and then 3 things have to be true. The first thing is that f of a has to exist. It has to be defined. So you have to basically have a y value at that specific point. Okay, the second thing is that your left and your right limits, so as you approach A from the left, has to be equal to as you approach A from the right. So the left and the right limits have to be equal to each other. Okay, if the left and right limits are the same, then that means that you can take away the plus or the minus and just put the limit as x approaches A. And that needs to be equal to f of A. Okay? So we're going to look at our pictures at the top, and we're going to see which part of the definition each of those pictures breaks. Because we know they're not continuous, because we already talked about that. Okay, but let's talk about specifically with the definition, how do we know what part of the definition they break? So look at your first graph right here. Is f of A defined? Well, let's say that this is A. Is there a value for f of A? Yes or no? No. Okay, what if I put f of A up there? Now does f of A exist? Yes. Okay, now go down to step 2. Are the left and the right side limits equal to each other? For the first graph. Yeah, as I come in on this side and this side, they're both approaching the same number, but what about step 3 now? My limit is the open circle, but my f of A is the closed circle. So is step 3 going to be true for that first graph? No. Okay, look at the second graph. Is f of A defined? Here, we're going to pretend like the breakpoint is A here. Okay, then is the left and right limit equal to each other?
No.
No. Left limit's down here, right limit's up here. So that would be step 2, doesn't work. Okay, third one. F of A has to be defined, is it? Yes. But are the left and the right limits equal to each other? Which limit do you need?
The right.
The right side. Very good. Make sense? Sure, this one? So look at graph 1. For this graph, your limit as x approaches A is going to be where the open dot is. So I have a limit. My left and rights are going to the same spot. But f of A refers to the y value, which would be your closed dot. So those have to be equal. You can't just have both. They have to also be the same. So this would be not continuous because step 3 is not true. Okay? Make sense? So it takes like a pretty easy concept, draw it without picking up your pencil, and it like makes it very defined. So what's going to happen on the AP test is you're going to have to use that definition to justify why you're saying it's continuous or not. If you put, well, I could draw without picking up my pencil, then you're not going to get like any points for that. Okay, sadly. So, first question, is f of x continuous at x equals 3? And your function is going to be piecewise and we're going to use the definition, the 3 parts, to determine whether it is or whether it's not. Okay, so flip back to your notes if you need to. What was the first step? What has to be defined? Okay, now what's our A here? 3. So we want to know, is f of 3 defined? Okay, well, can I plug it in? Which part? Top or bottom? Bottom, because that's where the equal to is. So I'm going to plug 3 in right here. So it'll be 3 plus 2. What is f of 3? 5. Very good. Step 2. What do I have to check next? The limits. Good. So I'm going to find the limit as x approaches 3 from the left. I'm going to find that number. And then I'm going to find the limit as x approaches 3 from the right. This is what we did yesterday. Now, I already plugged into the bottom and I got 5. Is that the left side or the right side limit? Right. So I'm just going to copy my 5, okay, because I already found that. That was the bottom part. The left side, I'm plugging into the top. So 3 squared minus 5, I'm plugging in now right here. 3 squared is 9, take away 5 is 4. So I got 4 on one side, 5 on the other side. Do I move on to step 3? No. What's our conclusion?
It's not continuous.
Good. Therefore, 3 little dots, you'll use these in geometry, yeah? Or no? That just means like therefore. It's kind of formal. Okay, you wouldn't like get in trouble if you didn't put it on the AP test. But therefore, it is not continuous at x equals 3. Okay? Yes, ma'am.
Back to the notes.
Mm-hmm.
I
Are you talking about the steps?
didn't.
Yeah. Let me write down the next problem and then I'll give it to you. Okay, next one, f of x equals. This is going to be a 3-part piecewise. And your breakpoint's going to be 0, 3, greater than 3. Does anybody else need me to go back to the steps? I will. Anybody? Okay, so this number here we said yesterday is called the breakpoint. So how many breakpoints do we have this time? 2 breaks in the graph. So we're going to do 0 first. We're going to do 3 second. So at x equals 0. Okay, step 1, what do I do? Okay, f of 0, yeah. But that's our a. So we want f of 0. Where are we plugging into? Top, middle, bottom. We want the one that includes 0, so that would be the middle. Or I'm sorry, no, not the middle, the top. Okay, because that's where our equal to is. So e to the 0 plus 4. What's e to the 0? 1 plus 4 is 5. That's our y value. Step 2. We need to do our limit as x approaches 0, the breakpoint from the left. And then our limit as x approaches 0 from the right. Now remember, 0 is our breakpoint, so we're going to plug in for the left on top, for the right on bottom. Yes, sir?
Wait, what is that in between the zeros? What is that? Is that a...
Oh, that should be an that should be an x.
Oh,
Oh, sorry. That's x less than or equal to 0. My
okay.
bad. Thank you.
Wait, I didn't know which one's the breakpoint again.
The breakpoint would just be where you switch from one function to the other. So like these both have a 0 in common, so that's their breakpoint, and then 3 is the breakpoint from the middle to the bottom set. Okay? So remember, the top part is going to be your left side. So we already plugged into the top part. What did it come out to be? So put your 5 right there. And then now you're going to plug in 0 to the middle section. That's going to be the right limit that you're going to put right here. So if I plug in a 0 right there, that's 2 times 0 is 0, plus 5 is 5. So left and rights both came out to 5. Is that the same as the y value? Yes. Okay, I'll put right here, this was 2 times 0 plus 5. That was how we got it. Okay? So then for step 3, if my left and right limits were both 5, then my limit is 5 without a plus or minus, and that's equal to f of 0. So what's my conclusion at that point?
It is continuous.
Therefore, continuous at x equals 0. Okay, you do it at 3. So now we're going to check it at x equals 3. And you can do it in just like one line practically. Why can you do it in like one line? What are you supposed to find first? F of what?
A.
Okay, what's our A for this part though? 3. So I want to find f of 3, yeah? But what part includes 3? Neither one. So you can't pick which one to plug it into, so what would you say about f of 3? Not DNE, it's undefined. Very good. And that's your step 1, is that you have to be able to plug it in. So if I can't plug it in, my first step is that f of 3 is undefined. Therefore, not continuous. Make sense? Okay. I want you, real quick, to look at your homework, and I want you to do number 2. We don't have tons of time to do it, but we didn't do an x equals 1 and an x not equal to 1. We covered it yesterday, but I want to see what you guys remember. So on your homework, you're going to do number 2. There's an A and a B. The question is it continuous at its breakpoint? What's number 2's breakpoint?
1. Negative 1.
Negative 1, good. So you're doing number 2 off your homework. And just follow those same 3 steps. Yes, sir? I do. This cupcake.
Is it also an eraser?
It is. It used to have a little cherry on top, but then I erased too hard and it fell off. You should have thought that through better.
She's a really good sharpener.
It is? Thanks, I got it at the book fair. Okay, part 1. What's g of negative 1? Which part do I pick? 2. Okay, that's the bottom part. For the limits, we covered this yesterday, where do you plug into? Usually it would be both, but if it's an x not equal to negative 1, that's both sides of the limit. Y'all remember that yesterday? Okay, if it's a not 1, that means all the numbers where x is less than 1 and all of the numbers where x is greater than 1. So that's your left and your right side limit. Okay, so those are tricky. All the other ones you can just do top and bottom. But if it's a not 1, that section is both sides of your limit. So when I plug in negative 1 to x squared minus 8, what do I get?
Negative 7.
Yep. Negative 7, negative 7. But again, why are we plugging into the same side? Because not 1 is both sides. Okay, then your step 3. Those 2 steps needed to be equal to each other, were they?
Yeah, no.
No. So limit as x approaches negative 1 without a plus or minus is not equal to g of negative 1. So the limit that I was approaching is not the same as the y value that I have at that specific point. Okay, then it says to sketch a graph. Negative 1 is here. Where is my y value at negative 1? 2. So I'm going to put a dot here. And then everywhere else on the graph, when x is not negative 1, I'm using x squared minus 8. What shape is that?
Parabola.
Parabola, how's it shifted with the minus 8?
Down 8.
Down, and where's the hole going to be at? Where was the limit at? Negative 7. So I'm going to put it like here, and then draw my parabola. So my value is at 2. My hole in my graph is at negative 7. So my conclusion is that it is not continuous, which I forgot to write. Therefore, not continuous. Yes? So when you're doing x not equal to negative 1, so that would be this side of the graph and that side of the graph. So that's why you only plug into the top, because it's not x less than or x greater than, it's x not equal to, so that's actually both sides. Okay? Alright, then I want you to do one more thing and then we're going back to your notes. Put an equal to on the top there.
So the open circle would be at negative 7.
The open circle would be at a height of negative 7. Yes, ma'am. That's correct. Here, this is where you're putting x less than or equal to 0. Okay? And we will come back and do that one if we have time. Okay, back to your notes. Good? Questions? Okay. Thank you. Okay, the next thing that you are going to do is, oh, I forgot one. F of x equals, forgot our trig example. Cosine x plus 2 on top, 2x in the middle, sine x plus 1 on bottom. Your breakpoint is going to be x less than pi halves, x equals pi halves, and x greater than pi halves. Okay, you're going to use the definition to determine if it's continuous or not. What do we do first? Okay, what's our A? Pi halves. So we want f of pi halves. Where are we plugging into? Top, middle, or bottom? Okay, that's going to be included in the middle. Very good. We're plugging in pi halves to 2x. What's going to happen? What are we going to get? Pi. Because the 2 divided by 2 crosses out to a 1, so we don't have to write it, so it's just pi. Okay, step 2, I want you to find your limits. Where are you plugging into for the left limit? Top. Where are you plugging in for the right limit? The bottom, because the equals is in the middle. So this is your left limit. This is your right limit. Okay? So plug into each of those. I'm going to give you a couple, maybe a minute to think about it. Remember your hand trig. Which one is pi halves on your hand? Thumb. Good. Okay, what is cosine of pi halves?
0.
Yes, that's right. I didn't think about it. Okay, it is 0. Oh, and that should be a 2 here. So then what is 0 plus 2? 2. Okay, let's do our other side. Sine of pi halves? What's sine of pi halves?
1.
1 plus 1 is 2. Did they come out the same? Okay, now the limits came out the same to each other. Did they come out the same as the y value? No. So then in our third step, we would put the limit as x approaches pi halves of f of x is not equal to f of pi halves. And that is a problem, therefore we conclude it is not continuous at x equals pi halves. Okay?
The third step is that the first two steps have to like match.
Yes, ma'am. Good? Questions? Alright, next one. We have 3 more left. Just 3 little problems. Okay, you are going to find the value of k so that f is continuous. Find the value of k so that f is continuous. Here's f of x. Piecewise function, top piece is kx squared. Bottom piece is 2x plus k. Your breakpoint is going to be 2. Okay, ideas? Think about it. We want f to be continuous. We need to solve for k. Yeah, we are going to need to work backwards. We're going to need to do some solving. What do you know about this top side? It's representative of which limit? Left limit. What's this one? The right limit. If it's continuous, what do those have to be? Equal. So we're going to set them equal. So I'm going to let kx squared be equal to 2x plus k. Now, question. Do they have to be equal everywhere? No, only at the breakpoint. What's the breakpoint? 2. So I'm going to plug in x equals 2. So remember, that definition tells me the left and the right limits have to be equal, so I'm setting them equal, and then I'm plugging in the number they have to be equal at. Okay, so from here, plug it in. What is my left side, kx squared, going to come out to be? Okay, 4k, so it'd be k times 2 squared. Then I have 2 times 2 plus k on the other side. So we said this was a 4k. That is correct. What about on the other side? What now? What do you do? Don't divide by the 4. Can't subtract 4. Okay, good. It's been all summer. Okay, it's okay. It's okay. Get it? Oh. You have to take away the k to get them on the same side, right? Because you can't divide if there's k's that are separate. You need to combine like terms. They need to be on the same side. So 4k take away a k is how many? 3k. And then if 3k is 4, then k is what? Divide by 3. 3 ends up on the bottom. So k would be 4/3. Good. Okay, we're going to do 2 more like that. Then we're done. Good. Okay, next one is going to be f of x equals x plus 11 on top. People still need that? X plus 11 on top. I'm giving you the next function, but some people are still writing. And the bottom one will be ax squared plus 4x plus 5. Breakpoint's going to be -4. Okay? I'll write it up here in a second. Okay. X plus 11 on top, and ax squared plus 4x plus 5. Breakpoint is less than -4, greater than -4. Okay? And you're finding A. Yep. Okay, careful with your signs. You're going to get a fraction on this one.
Are you going to get a fraction for the answer?
I thought so. No?
No, I can.
Yeah, you should have.
Oh, crap. Oh, wait, no.
You should get a fraction that's the top and the bottom are both even, and then you have to reduce it. One of the digits is a perfect square. The other digit is a perfect cube. Okay, here it is. No, it is a plus. It should be a negative on the 16. Oh, yeah, because it's negative 4, yeah? Your 16 should have been negative. Anybody get it? Forget?
9 over 4.
Nope.
Wow,
Over
nice.
8. I was really excited for you in my heart, though.
Crap.
Okay, so let's look
yeah,
and see.
Yeah.
Yeah? Okay, let's see how we did. So you should have had negative 4 plus 11 equals a times negative 4 squared, 4 times negative 4 plus 5. Okay, negative 4 and 11 makes 7. This is a positive 16 because the negative goes away. This is a minus 16 and then a plus 5. Negative 16 and 5 combine to be a minus 11. And then I have to add that 11 across before I divide. So I'm going to add my 11 here. And then if 16a equals 18, what's my last step? So then a would be 18 over 16. Both of those are even, reduces to 9 over 8. Make sense? Okay, we have one last one. This time you're going to have 2 missing letters. Okay? Alright, the last one is going to be f of x equals. Ignore the top part there. F of x equals x squared plus 5 mx plus 3 plus k and 2x cubed plus x plus 7. 2. Okay, how many pieces does our graph have? Which means how many breakpoints? 2. How many letters are we going to need to find? There's an M and a K. So think about for me, we're going to find values of M and K. Yes. Okay, I don't know if y'all heard what Megan said, but she said we're going to find one, and then we're going to have to go back and substitute to find the other. We're going to use basically a system of equations, okay? So what 2 things should we start setting equal to each other?
The top and the bottom.
Top and bottom? They have to have a breakpoint in common. So top and middle. So I'm going to set this one and this one equal to each other. And what is their breakpoint between the top and the middle? 2, because that's the number that they both have. So I'm going to let x squared plus 5, mx plus 3 plus k, and then I need that to happen at x equals 2. Then what's my next step going to be after I set the top and the middle equal? Set the middle equal to the bottom, and what's their breakpoint that they share? Negative 1. Make sense? So I'm going to go ahead and set up my next step here. It's going to be m x plus 3 plus k, 2x cubed plus x plus 7, and then I'm going to plug in negative 1. And do we understand how to choose which breakpoint? It has to be the number that's in both parts that you're setting equal. Okay, so work that first part down to a substitution. So you're plugging in 2. What's the left side going to be? Okay, 5m plus k. Which letter will be easier for us to solve for? Then pick the easy one. So we're going to take our 5m, bump it across here to the other side. When it switches over, it's going to turn what? Negative. So it's going to be k equals 9 minus 5m. Okay, and we're going to use that later to come back and solve. Okay, now look at your bottom chunk. Your number's -1. Plug it in. Okay, let's do some PEMDAS here. P in PEMDAS stands for, okay, what is -1 plus 3? So that's a 2m plus k. Other side, oh God, my voice is dying. What comes after P in PEMDAS? E stands for exponent. What's -1 to the 3? Still -1. Times that by 2? -2. Then I have a -1 and then a plus 7. Okay, we're going to combine left to right. What is -1 minus 1 more? -3, then plus 7, 4. So I have 2m plus k equals 4. What do we do now? Yes, your substitution. Okay, go ahead and do that substitution. You should get a fraction. Okay, so I'm going to take this piece up here, and I'm going to sub it in where my k is, right here. So I'm going to have 2m plus, then when I get to k, I'm switching out for the 9 minus 5m. What's our next step? Combine like terms. What's 2m minus 5m? -3m. Still a plus 9 that we have to get rid of. How do we get rid of the plus 9? Subtract the 9. What is 4 minus 9? -3m is -5. Last step. Yep, divide by -3. And m is 5/3. Okay, what was our initial instruction? To find what? M and k. What do we do then? Yep, got to go back and find k. Now, there are several places you can go back and find k from. The easiest one, though, is going to be your substitution step. So we're going to go right here. K equals 9 minus 5 times m, which is 5/3. Okay, a little bit of fraction work here. I'll say two things, though. On the free response, if you suck at fractions, you leave it alone, just like this. You're done. On multiple choice, this is the bad news. They're going to make you do it. So we're going to practice it in class, but know that half of the test, if you left this alone, it wouldn't matter. Okay, it's only on that multiple choice that you have to be able to pick which answer you want. You will have to work with fractions. So when you are multiplying fractions, how do you do it?
Top by top, bottom.
Top and top, bottom and bottom. So what is 5 times 5 on top? 25, and then 3 times 1 on bottom? 3. Now we need to get a common denominator. We are going to multiply 9 by 3/3. We're going to multiply 9 by 3/3. On top, what's 3 times 9? 27. And then on bottom, since there wasn't anything on bottom anyway, it's just a 3 now. And then 27/3 minus 25/3, they have a common denominator, so I just take away on the tops. 2/3. Very good. Make sense? Okay. On your homework, I want you to turn over to the back, and I'd like you to try number 10. Number 10. And you guys can work together, obviously it's fine. And you should get a fraction. Yeah, that's right. Good job. Once you get 10, I want you to read 12. See if you can figure out what to do on 12. Anybody have an answer for 10? What is it? 3 over 2. Isn't it 3 over 2?
Yeah.
And if you need help, raise your hand. Or ask somebody next to you, okay? So once you get number 10, I want you reading through number 12. Three over 2.
Just reading it.
Oh, and go ahead and start it if you know what to do. Okay, part A. So number 10 we said should have been 3 over 2. Hopefully you got that. Okay, number 12, what are they asking you to do in part A?
Substitute one straight.
Determine whether or not it's continuous. But they gave you a number for A. So remember, in this form, A is anything. But for part A, we're going to pick what number? 1. So I'm going to rewrite f of x equals, this is only for part A, it's going to be x plus 1 and 1 x minus 5 squared. Less than 2, greater than or equal to 2. What are they asking you to determine now? If it's continuous. So you have to do your 3 parts. What's part 1? Instead of A, f of... Where's the break point? 2. So you should be finding f of 2. Then what are you going to do after that? Okay, limit from the left and the limit from the right. And then if step 1 and step 2 go well, in step 3 you'll check to see if they are equal to each other. So f of 2, where are we plugging into, top or bottom? How do we know? Equal to, so I'm doing 2 minus 5 and then squared. We're kind of ignoring the one in the front because it's not important. 2 minus 5 is negative 3. Squared is negative 9?
No.
Positive 9. Good. Okay, then on my other part, 2 from the left, top or bottom? Top part, 2 plus 1 is 3. Do I have to plug into the bottom again? We already know it's 9. So what happens in our graph? Step 2 is not true, so it is continuous or not? Not.
That's what I did. Yeah, that's what I did.
Okay, that would work too, yeah. As long as you showed your work well, that would be fine.
Even on the 10th, the AP.
Yeah, that would be okay.
And I just said that,
So you plugged in A is 1, X is 2, and then just saw if the sides were the same?
Yeah, and then I got the 9 and the negative 3.
Okay, yeah, that's fine. Okay, now it says to sketch it. So what would it look like? My break point is where? 2. Okay, 2 is x plus 1. What shape is that? Okay, it's so the first part's linear, right? Goes through 1, and then at what height is the left limit approaching? 3. So here's my hole on my graph, and my graph is going up towards 3, and then it stops. Then at 2, I switch to my parabola. Okay, where's the hole for the parabola graph? And I didn't mean hole, I meant point. Where's the point for the parabola graph? How high? -9? +9. So up here. Okay, now this is just bonus for fun. Where do I know that this quadratic hits the x-axis? If it's x minus 5 squared. +5. Do you remember this shifts it over 5?
Yeah.
So, and that's not really that important in this case. But this point would be 3, 4, 5. Okay, just based on the fact that x minus 5 squared is shifted over. Okay, and looking at the graph, what kind of discontinuity is that? Choices are removable, jump, or infinite.
Jump.
That's a jump. Very good. Go to part B. Find the value of a that makes it continuous. What are you doing in part B? You want to make it continuous. Set them equal to each other and plug in what number? 2. So you're going to set x plus 1 equal to a x minus 5 squared. And you're going to let x be 2. And then you're going to find a. Okay? No, the only reason we had to do that was because 2 letters were missing. So this one only has an A. Yeah? But if there's 2 letters, you'll have to do a substitution. Okay? Huh?
What does it mean when it says use the definition of continuity to justify?
So that's like the 1, 2, 3. So where you're breaking up the points. Okay, is the clock like on time? Or are we ahead or behind? 3 minutes? Okay, I want to just look at that number 4 that we skipped, or 5. Oh, because I can't number. 1, 2, 4, 5. Off to a good start. Okay, is G continuous? What? No. Oh, there is a number 3. Good. Okay, what do we do first? Find f of, okay, step 1, what is it? F of 0. So 1 plus 0 squared, what do we get? 1. Step 2, I want to check the limit on either side. The limit from the left is going to be 1. Because that's the top part, and I already did it. Okay, but the reason that we're doing this one together is that I bet some of y'all forgot about ln. Okay, what is the graph? That is natural log, true. Okay, but what does the graph look like? Okay, I'm going to draw it for you in the corner here. Yeah. Okay, and it has an asymptote at 0. Do y'all remember that? Okay, ln x does not exist at 0. So what would you say about the limit as you approach 0 from the right? DNEs. What kind of discontinuity is it? Infinite. Okay. So you'll just put therefore not, right? Okay. Good job. Good job, people. Proud of you guys. Homework 1 and 2 are due tomorrow, not this one, because you just got it. Only 1 and 2, and they should both pretty much be done. Yes, and it'll be open notes. That'll be due next Friday. So you have plenty of time.